And in this video, I'm going to be explaining the XAI techniques for our models, that is the explainable AI. To begin with, explainable AI just helps the models to understand and implement, and in the understanding and implementing of the model. So here, uh, I'm going to focus on the base two and the worst two models. So far, my best two models were vision transformers and attention networks models. And then the worst two were capsule networks and contrastive learning model. So to begin with the benefits for explainable AI, it brings transparency, that is, helps models to be clear while making explanations. It also brings trust and accountability. So it helps people or machine learning engineers to build trust in what the models they have implemented, and also helps in debugging and improvement of the model, that is, identifies the biases and weaknesses in the model, and also uh, helps in regulatory compliance, which helps to ensure that the systems meet the legal ethics or standards while developing these models. And it also helps in bias detection, that is, helps to uncover the biases in the models. Like you might have developed a model that is performing well, but again, it has some biases while implementing on the data. And these are the techniques I applied. I use silence map, line, and attention maps. My data set is an image data set. That's why I chose these ones. To begin with the silence map, this one, like a visualization tool that helps to highlight most important pixels that are influencing in the model's prediction. So here, this one is going to help in focusing more by using pixels uh, depending on the final prediction of the model compared to the other surrounding areas within the image. So one of the image for my best model for vision transformers, I try to show that, as you can see here on the right hand side, I try to focus where the image is, and you see whether there is the dark red, like the red or maroon. That shows that that's where the image is. So it's trying to focus there. Another one was for attention networks, where the image was not clear enough, but try to focus. For the worst models, as you can see, the models didn't do work very well. That's why it's not focusing very well. And then for contrastive learning, it shows that it's focusing a lighter color. That it shows that it hasn't seen the image, or it's not, the model is not working very well. To continue with line, for line for it, it helps the model by locally, by approximating or locally, by interpretable approximations. That is, when you input data in the line architecture, let's say the code or the model, it's going to use, or it's going to, since I'm using an image data, it's going to use this image and segment it into super pixels. And the super pixels, these are the small coherent image regions. Instead of using in video image pixels, for it, it uses the super pixels, the small coherent image regions. And these were the sum of the images that I used. Here, as you can see, we try to map around there is some blurry feature in the image that try to focus in the image, and that was the vision transformers model, and then that is the attention networks model image. For it, the image I selected was not clear, but try to implement. Then this one is for capstone networks. Try to also get, I think you can't see it very well, but it brings in the future, the line technique brings in the future within the image. That one is for contrastive learning. And the last technique or the method I used is attention maps. And for it tries to focus in the area of the image where it is, and brings in the higher weights, which indicates a stronger attention for the model. So it focuses more where the image is. So as you can see here, this is the vision transformers model. It try to focus within where the image is and try to draw to visualize it like this, how the model sees it. And here, this is the attention. We try to also focus more where the image lies. That brings me to the end of my presentation. Thank you.